Okay, you guys, in this section we're talking rational functions. The goal is to simplify, multiply, divide rational expressions and functions. We'll talk about the difference, what's a rational expression versus a rational function. We'll talk about that momentarily. First, the definition of a rational function is it's a ratio of two polynomials. So, well, a rational expression, that is. It's a ratio of two polynomials. So let me give you a quick example or two. So if you took just a regular fraction, I mean, technically, 5 is a polynomial. A constant is considered a polynomial. It's a really boring one, but it's considered a polynomial. 6 is considered a polynomial. So technically, the rational number, 5, 6, is a rational expression, but that's kind of a lame one. So let's think of a polynomial. How about x squared plus 7x plus 10? That's a polynomial. And then if you divide that by another polynomial, maybe x minus 8. So that would be a rational expression. So how do you turn it into a rational function? Just set it equal to y or set it equal to f of x, and it does turn out that it passes the vertical line test. And that's what this note is about down here. So if you take this last one and set it equal to y, so say y equals x squared plus 7x plus 10 over x minus 8. What's the difference between the two? Well, this has two variables, right? This has an input of x. Oh, there's another x right there. So it has an input variable, and then we've also named the output variable, y. And so there's always a chance it's a function, y equals f of x. When you do that, y is some formula in terms of x, and it does turn out that it passes the vertical line test. So it is a function. And that's what this note is saying. If you set y equal to a rational expression, it's a function. So if you just want to know the difference, a rational expression is not going to have an equal sign, right? It's just a single formula. Whereas a rational function is going to have an equal sign and another variable. So in this example, let's let f of x equal x squared plus 4x minus 9 divided by x minus 4. We just want to evaluate. In part A, f of 0. So what is it? This is back to function notation. What does f of 0 mean, you guys? Plug in 0 for x. So we've got our rational function defined by the formula x squared plus 4x minus 9 divided by the quantity x minus 4. Replace x with 0. And what are you going to end up with on top? If you put 0 in for x squared, 0 in after the 4, what's the only thing that's not going to go away? The minus 9. So you're going to end up with minus 9 on top and 0 minus 4, or just negative 4 on the bottom. So f of 0 is equal to negative 9 over negative 4, which I guess would be the same as positive 9/4. Well, 0 kind of makes it easy to evaluate. So let's do a non-zero one. In part B, f of negative 2. So wherever you see an x, the input then, x is your input variable. It represents a generic input. In this case, when you see f of negative 2, that means, oh, your input's negative 2. So specifically, replace x with negative 2. And you get, is this the right way to write it for x squared, replacing x with negative 2? Is that the word? No, what's the right way to write it? Yeah, because you're squaring the whole thing. When you write it without the parentheses, it's the opposite of 2 squared, which is actually negative 4, because you square first and then you take the opposite of it. When you write negative 2 in parentheses and square it, it means take negative 2 times itself. And negative 2 times negative 2 is positive 4. So there's a big difference there. Plus 4 times negative 2 minus 9 on top, all over negative 2 minus 4 on the bottom. All right, help me out here. What do we get on top? Well, we don't have to do it all at once, but you should evaluate what first? Probably the exponent? So what's, oh, well, I already said it. Negative 2 squared is 4. And then what? Plus or minus 8, plus a negative 8, minus 8, minus 9. What do you get on the bottom? Negative 6. Okay, on top, 4 minus 8, negative 4 minus 9. So you get negative 13 over negative 6. And how does that simplify? Same as 13 6. Everybody buy that? Okay. Part C, we want to take f of 4. So I want you guys to stare at the function and then stare at f of 4 and tell me what's going to happen here if I try to plug in 4 for x. Yeah, is it okay to divide by 0? No, it's undefined. So are you going to bother plugging 4 into x in the numerator? No. Once you see that you get 4 minus 4, the denominator is 0 in the denominator, you just say undefined. And in fact, what it really means is 4 is not in the domain of f, right? Remember what the domain is. It's the set of all inputs that you're allowed to plug into the function. So 4 is not in the domain of f. In fact, what is the domain of f? So D for domain. How about DOM? How about DOM f? D-O-M-F. What is the domain of f? Is there anything else you can't plug in besides 4? Anything else that's going to cause division by 0? I don't think so. So what's the domain?
Set of all x that x does not equal 4.
Yeah, set of all, using set builder notation, curly bracket, x, vertical bar. That means the set of all x such that x does not equal 4. And then when we write it this way, we assume x can be any real number other than 4. Right? And we've actually done problems like that before. We just didn't know that they were called rational functions, right? Where we found the domain by looking at the denominator and seeing when it's equal to 0. And then restricting those values, in this case, just one value. Does that make sense? Okay.